So in this tutorial, we are going to model a supply chain network. This illustrates what we are going to do. You can see here in the green houses for retailers. We have in Emshaven a wholesaler located, and the producer is in Groningen. And now the producer sends items to the wholesaler. For that, the producer has their own fleet. And then the wholesaler distributes based on the customer demand the items to the 4 retailers. And therefore, again, the wholesaler has their own truck fleet. And we are using the GIS network so that we can use existing roads to avoid having some approximations in our model. The purpose of this video is rather simple. You will find a step-by-step tutorial, and I try to follow those steps in this tutorial. And in total, we have to fulfill 71 steps to have this runnable model. So what I would like to show you next is the Anylogic model itself. So let me switch to Anylogic. So here we can see the final product we are going to model together. If I'm going to run it, then I select for the supply chain network, the Java applet is generated. The Java applet is here. And we let the model run. Now the data is downloaded from the internet because the maps are not stored locally. So whenever you run the simulation, then the new data regarding the maps have to be downloaded. So that might take a while. Now you can see how the model is behaving. As I explained, trucks are delivering the produced items to the wholesaler. The wholesaler trucks are delivering the items to the retailers based on the customer demand. And the planning strategy behind that is a Kanban between producer and wholesaler, and a Kanban between the wholesaler and the retailers. So let's get started. So then we are switching back to the Anylogic software. So in Anylogic, we generate a new model by Control N. Here the model appears. It's called supply chain. We save the model in a path we are able to relocate again when we need it. So I go to Courses and I save it in 1. Then we are going to change the model time. Unit is this. And then we are already done. Finish. Now the new model is generated and the main agent happens. Then we go to the palette space markup. There we drag and drop the GIS map into the model. We can enlarge it, the GIS map, because this blue area, which you can see here, is shown in the Java applet. So we can do a double click here. Double click, and then we can zoom in. We are interested in Europe. Takes a while because the GIS map is downloaded. Then we go to the Netherlands. Then we select the northern part of the Netherlands. Perhaps this is good. Then we can search already our first point, and the first point is the position of the retailer, which is located in Drachten. Here is the first point. We take that one, we transfer it to a GIS point. We double click on this point. We make sure that this point is named Drachten. And the second point is in Germany in Leer. Search it again. We take the first one. We transfer it to GIS point. Double click on it. Make sure that it's renamed to Leer. Third point is in Assen. Take again the first one, transfer it to the GIS point, double click on it and make sure that it is in Assen, and the final point is in Leeuwarden. I don't make a mistake, still hard to pronounce. Transfer it to a GIS point, make sure that it is saved as Leeuwarden. Double click again in the main so that we get out of the search area. And I would like to show you what we have done so far. If you open the main agent presentation, you get the map which we have introduced, and then you can see the 4 points, the 4 GIS points of our retailers. And we need that to get into a collection. So we mark all points by using Control, right mouse button, and then we create the collection. Collection name, I'm not happy with that because we have to transfer the name here, retailer location. And this is perfect. Here you can see again our 4 GIS points. You can easily add with the plus new GIS points if you have more than 4 retailers, and of course you can delete them easily by the red cross. So this is now point 9, and we continue to point 10. There we have to generate our retailer agents. So we switch to the palette. We go to the agent palette, and then we select and drag and drop the first agent into the main one. We select population of agents because the retailer consists of 4 agents. We rename that one to, let me see, retailer, just retailer. See, we create it from the scratch. Next one, we select the 2D visualization, and then we select the retail store. Next, we do not need any additional parameters for that agent, and the population is initially empty. Finish. So the agent is generated, and now we have to make by ourselves the initial size. So the population is not empty, it contains a given number, and the number is stored in the retail collection. So we have to count how many retailers are within our retailer location collection. So retailer location, and the simply Java order for that is size, brackets. Then we also have to define where this location should be visualized by our beautiful mouse. So the initial location the agent placed is in a node. Then you have to click on the equal sign here to get the dynamical coding frame. And there we again refer to the retailer location collection, because there the GIS points are stored. And then you need just to get back the index, which location you're referring to, 0, 1, 2, or 3. Therefore, we use the get function, and index means the 1, 2, 3, and the 0. So once you have done that, I use semicolons just for a single line, which is not really necessary, but a good advice to do that. And then finally, we can run a model. The Java applet is generated. That might take a little while because the data of the maps have to be downloaded from the internet. We are using the OpenStreetMap, and we can see already the 4 beautiful houses of our retailers. And soon the download is completed, then we can check also the location. So it's Leeuwarden, Assen, Leer, and this is Drachten. So the visualization is exactly what we would like to have. So we can close that one. So now we have to search the GIS point for our wholesaler. So double click again on the map. The wholesaler is positioned in Emshaven. So we enter Emshaven, we search Emshaven, and it's the first point. We transfer again to the GIS point, double click that it is stored, double click. It's Emshaven, so we are done so far. We can check that again. If you go to the map, we can see that we have now Emshaven. Now we can generate our agent for the wholesaler. So we drag and drop the agent into the model. In this case, it's a single agent because we only have one wholesaler. Before we had the population of agents because we had 4 retailers. So single agent, I want to create an agent. The agent is called wholesaler, created from the scratch. We need a visualization, therefore we have a beautiful warehouse, which is yellow. Next, we do not need any parameters and we can finish. So in this case, there is just a single population, so we don't have to find the initial population. But what we have to do is to define the node, and the node is Emshaven. So now we have done point 16. Continue with the producer, point 17. So we again double click here on this beautiful map. We search the GIS point for the producer, and the producer is located in Zernike. Enter Zernike. We take the first one, we transfer it to the GIS point. We make sure that the GIS point is renamed Zernike. This is done. Then we can drag and drop the agent in agent. It's again a single agent. We select, I want to create a new agent. The agent is called producer. We create it from scratch. Next, we select a 2D visualization and then we take the factory. Finish. And then again, the initial population is simple because we only have a single agent. We select the node in the initial location and the node is Zernike. And then we can run the model. The Java applet is generated again. And hopefully we can see now the 4 retailers plus the warehouse, the wholesaler, which is in Emshaven, and the producer is located in Zernike. So everything is here, and this is what we have done so far. And now we have finished step 21. So some agents are missing, so we have now to generate the agents for the trucks. That means we drag and drop again an agent into our model. And this is a population of agent because we have more than one agent. We create it again. We create a new type. Next, the agent is called truck wholesaler, WS. We create it from the scratch. Next one, we have a 2D visualization and we select a lorry. Next. And for that agent, we need parameters because we need to transfer the locations where the trucks have to go. And therefore, we click here on New. The parameter of the location is called client. And this type is an other type because it should be an agent. And it's the retailer agent. So this is done. And we can continue with next is initially empty and finish. Then we get our parameter trucks for the wholesaler. And now we would like to initialize the number of trucks. Therefore, we take a parameter into our model. We name this parameter number of trucks WS for a wholesaler. It's an integer parameter, and we just define according to the outline the initial value to 5. Now we can click again on the trucks. We define the initial number contains a given number of agent, which we have defined in the parameter number control space, and we search the number of trucks. So now we have transferred the information of this parameter, the 5, into the initial population. Then we have also to select the GIS point. So the initial location is Emshaven. And that's it. We can do the same for the trucks of the producer. So we drag and drop again an agent into this model. We first, of course, select the population because we have more than one truck. I want to create a new agent type. And the agent is now truck R for producer. We created from the scratch. We select the beautiful 3D model, and this is now the truck. Next, we again need the parameter, which is called client. There we store the information where the truck has to go. This is an other type, and here we select the wholesaler. That's done. We click next, initial empty, create initial empty population, and finish. And the agent appears. Then we do the same procedure that we introduce a parameter indicating how many trucks we have, number of trucks for the producer. This is an integer parameter, and the initial value is 5. Then we go back to the agent trucks, and we assign the parameter contains a given number of agents. This is stored in number of trucks PR. Then we select the initial location, which is stored in a node, and the node is Zernike. Now we can run the model again. Model is initialized. Just to see what has happened. Now we can see that the trucks are very, very big. We don't like that because then we can't see the rest of the model. So we open the first agent, truck PRs. Then we select the visualization object. Then you can see the scale, X and Y. So we divide it by 2. Means we multiply it by 0.5. We do that as well for the other agent, for the truck agent. Double click on it. Select the agent, the position, the X. We set it down by divided by 2. The same for the other X. Then we can run the model again. We wait until this beautiful Java app appears. And now we can see there are sizes much smaller. Good, so we have done now step 27. So we continue with the generation of the order agent, which is step 28. We drag and drop an agent into our model. Then we select agent type only because we only want this agent to be assigned when a customer order is generated. So as we have done it for the on-machine model, we assign all generated order agents to the order type. So we select agent only, agent type only. This one is called order. We create it from scratch. We don't need a visualization, but we need parameters. The first parameter is the customer retailer. So we store there the retailer information. So we can select others and select the retailer. So next parameter we need is the prod underscore type. This is an integer. Next parameter we need is the quantity, which is again an integer. And the final one is the rifle underscore time. This one is a double. We can finish it. Then our agent is generated. Here we can see how our agent looks like. If you made some mistakes, you can correct them here. You can, of course, include more parameters if you need them for measuring key matrices. So now we continue with point 29. So we create the truck resource pool in the wholesaler. We switch back to the project view, open the wholesaler, and we go back to the palette. We select the resource pool. We rename the resource pool to trucks WS. That a little. Trucks WS. We change the capacity. The capacity is stored in main in number of trucks of the wholesaler. We select the resource unit to trucks wholesaler. We select the speed to 30 kilometers per hour. And then we go to advanced section. We switch to custom population. We click on the equation sign and assign the main truck of the wholesaler. This is not what I want. This is the wrong one. I need the truck wholesalers, the population of wholesaler. So this is fine. So then we are done with point 30. So we have now to open the producer. We do the same procedure for the producer. Back to the palette. We select the resource pool, drag and drop it into the model. Increase the view a little. We rename this resource pool to trucks production PR. The capacity is again stored in the main in the number of trucks producer. We change the resource unit to the agent truck PR. So dear Anylogic, be faster. I also would like to be fast. 30 kilometers per hour. And then we go to the advanced code, set it to the custom population. We click on the equation sign, and then we enter main trucks of the producer truck ERS population of the producer. Now we can run the model. If Anylogic is willing to start, happy to see something. And here comes the applet. What has changed to the previous step is that we now should see the amount of trucks if we can see a change. Yeah, so they are overlapping. But now there are 5 trucks here in Serneke and 5 trucks as well here in Emshaven. So this is point 31, 32, 33, and 34. So for step 35, I've already opened the Kanban example. So I select the agent Kanban, Control C, I want to copy it. I want to copy it in our supply chain model, Control V, and here is the Kanban logic. The problem is when you copy it, then also the references are copied. It's no problem. I show you how you get rid of that. So we are opening the Kanban logic itself. We go to the source, and now you can see here the problem. So we are still referring to the old model of the agent. So we select here our order agent. For the source, you have to make sure that here the change is done twice. So we go to the match block. We do the same check so that the input 1 and 2 is in order. We go to the batch block. Here again, the problem appears. So we select here again the order. And we do it for the unbatch. Here is the order. It's again the order. And then this is basically done. And now we go to the supply chain model itself. And then you can see that here under dependencies, the model is still referring to the model where we have copied the logic. So we can just debug it. And we see we don't have any mistakes so far. So what we can do now is that we can continue with step 39. So we are opening the retailer agent. So let's do that. So where's the retailer? We open the retailer agent. And now we can drag and drop the Kanban logic. And then let me switch to the outline. And now we are going to remodel this retailer according to that. So we need a source, sync, and an exit and enter block. So when I switch back, we go to the palette, the process modeling library. We enter the source. This one is named source 1. And in the source, we should change a rate to 7 orders per day. And we also change the agent to orders here, and advanced, it is done in this case automatically. And we need the sync, drag and drop the sync into the model. This one is called sync. The reason why it's 1 is that you can easily include your more product types, and then you need more sources. So the sync is renamed. We change the agent to order. Perfect. Then we need the exit and enter blocks. So we start with the enter block. Let's make it beautiful so that you see it more. I generate now connection. Then we are going to rename the enter block. The enter block is enter for wholesaler. The agent is an order. Then we need the exit block. The exit block here. Connect it. Fancy. Click on the exit block. We rename it according to the outline. It's the exit to the retailer. It's the exit to the next player in the supply chain, and this is the wholesaler. So, and then we have to give information that the agents are really taken to the wholesaler. But first, we have to store the information from which agent this order comes, because we have 4 different retailers, and we need to store the information which retailer is it. And this is done by storing the information to our agent, and we have already generated that in our order agent, and that is the customer okay, of course it's not working because this is not changed to order, and now it's working. Customer control space, and here is the customer retailer. And please remember, this is already an agent, so we can store all information of this agent by using this function. And now we send the agent get underscore main brackets, and then referring to the wholesaler. We're referring to the wholesaler agent, which we have generated by drag and drop in main. Then we're referring to an enter block, which does not exist so far because we have not modeled it, but take in mind we are going to use that in the wholesaler, and we send the agent to that point. Final one is semicolon. Then finally, according to step 43, no, it's already 44, we change the number of Kanbans to 1, Anylogic, and the lot size is 1 as oh. The prototype remains with 0. So when we run the model, we will get hopefully just 1 mistake. And this is the mistake I have already introduced you, that the enter block in the wholesaler is not existing. So we have to model that now. So, and to do that, we switch to our beautiful wholesaler. So then let me show again what we are going to do there. Here you can see the wholesaler logic, and now we are going to put this logic into our agent wholesaler in Anylogic. So back to Anylogic. Hello, Anylogic. So first step, we need again the Kanban logic. I can drop it into model. Here is the Kanban logic. Then we need an enter block. This enter block is called enter retailer, and this is now exactly this enter block we are referring. Now we are not getting this mistake anymore. So then we need another enter block. Cool. This is the enter block called production. Then we need an exit block where the items leave to production. That's the reason why it is labeled production, exit production. Then we need an cease block. Here is the cease block. This block is responsible to cease the resources defined in the resource pool. After the resource pool, we need a delay where the unloading, the unpacking is happening. That's the reason why we call that block unpacking. Then we need the release block. This release block separates the track agent and the order agent. So the next block is again an exit block. So where we are going to send the orders to the retailer back. So that's the reason why I call that one retailer, exit retailer. Then we need a move block, move to block. So where is my move to block? Need a help. Hopefully know what I'm doing. So where is my move to? Here's the move to block. And here finally the transport is executed. So this move block is labeled to wholesaler. So we go back to the wholesaler and we need here an resource end task. Going to explain you what's happening here then. But I first would like to do the first part here of the cease block. So we need the start of the resource task. Then we need a delay, which is called packing. We combine. And then we need again a move to block. This is called to retailer. And then we give this information. So today I'm really too fast for Anylogic. To the cease block. So then let me reduce the. So the order from the retailer arrives when Kanban is available. So products are available on the FGI of the wholesaler. Then the order is allowed to pass the Kanban block. And this cease block means, please, I'm here, I'm the order, and now I need a transport. And this is the information to generate a resource task start. And this agent then, in this case, the packaging happening means the loading to the truck. Then we send the truck to the retailer. So perhaps you recognize now how this is modeled, yeah? So we do first the packaging, then we send the truck to the retailer because the truck is owned by the wholesaler. And then we combine that together. So the cease block now combines the order and the track agent. And we have already done the transport to the retailer, yeah? We do the unpacking. Then we release those two orders. So the combination, the combining thing from the cease is now destroyed. And the truck goes back to the wholesaler and is waiting for the new order. And we are sending the order back to the retailer. And on the other side, when the empty Kanban is leaving, we send the order to the production. When it is produced, it enters again the enter production, and it is available in the FGI of the wholesaler. So now we have to model the logic behind, because now we just have drag and drop the blocks. So we go to the first block, to the enter block. This is rather easy. We change just the agent to the order agent. So then we go to the cease block. There we have to do a little bit more, because now we have to tell the cease block which resources are we referring to. So we press the plus button and we select the resource pool trucks WS for the wholesaler. So now the connection to the resource is available. So then we set that one to maximum capacity, because the cease block is a combination of more blocks, and one of those blocks is a queue block, so that you can see the visualization of the queue block. It's the reason why we have the functionality of the queue block here as well. Then we go to the actions on cease unit, and then we have to enter a beautiful code line. So two brackets, open two brackets, so you can see that. So Alex is moved to side. So, and then we do more or less a casting. So we change the type of the agent to another agent type, and the casting is done to truck WS, and then we go between the closing brackets, unit, point, client. This is the destination where the agent should go. And we give the information where the agent should go to, or is available in agent. And in the customer, so perhaps it would be a good idea to select first the correct agent, and we have the information available here. So the agent is the order. And if I do now press the control space, then I get the correct information, customer. That's the thing we have to do here. Then we go to the unpacking. We get rid of this stupid triangular distribution. Okay, it's not stupid, but we don't need it, because according to the outline, it should be a uniform distribution. And between 2 hours and 3 hours. So between 3, and the unit is selected to hours. Then please make sure that we select maximum capacity for that, and we also make sure that the order agent. So this was point 48. Then we go to the block resource task starts, this block here. So here we have to deal with the agent of the trucks, and more specific, the truck WS agent. Because now this is the line how the truck agent behaves, because the cease block orders a truck agent, and this is now what happens to the truck agent. So as I told you, we start with the packing. The packing is similar to the unpacking, so we have again the uniform distribution between 2 hours. So change the unit here, hours. We select maximum capacity. So that was point 48. Oh, 48. Change the block resource WS. So it was 50. And now we go to 51, to retailer. This is now an interesting thing. we make sure that the agent type is again truck WS. And then we select the destination. The destination is an agent. And we exactly know where the destination should be. And this is defined in agent point client. So we select that one. So now we have to send the agent, the order agent in the exit retailer back to its origin destination to satisfy the customer. In this case, we have a 1-to-4 relationship because we have 4 retailers, and we need to know where this where the order has been generated in which of the 4 retailers. Yeah, so this is a more complex situation, but we have already stored this information in the order agent, so we can just type agent, and we refer to the customer RT. Here the information is stored, and we tell which block we should go. It's the enter WS, and we use the take function and the agent semicolon. So if you remember, then, or I show you that, we go back to the retailer. Where is my retailer? Here's my retailer agent. And we go exactly back to this enter block. So we are satisfying this specific customer. So wholesaler, where are you? So this was point 53. So we have to do a similar procedure for the exit block of the production. So again, we make sure that all agent has type order. And now we send that one with the empty into the production. So we do that main producer. Now we have the problem that this enter block is not there because we have not modeled the producer so far. But nevertheless, we take the agent and remove it from this block and send it to the enter block. So then we finally have to change again the number of the Kanbans. So we have 1 Kanban. The Kanban lot size is 1, and the broad type is 1. So now we have to model as well the 2 wholesaler. I change the agent type to the truck WS, and the GIS point is agent unit, and we want to send it to the main wholesaler. So back to the destination origin. So when we now run the model, we identify that we get 1 mistake. And this is because, as I told you, we have not modeled the production so far. So this enter WS is not existing. But I want to show you a workaround. So we introduce a sync. It's fine. And we get rid of this connector here. So what's happening now is that we immediately destroy this empty Kanban bin. It's not produced because it's destroyed, but we should be able to run the model. We know that this mistake is here, so we can proceed. It's interesting that the Java applet always opens in different monitors. But here is it. So that was very fast to figure out what was happening. So I stop it again.
Perhaps I'm reducing the speed a little bit. And we can see that at least one truck was driving. And there is only the possibility that 1 or 2 trucks are driving because the Kanban, we only have one Kanban. This Kanban is now delivered. And in further time, we can also use the Kanban of the wholesalers. That's the reason why 2 trucks can deliver items to the customer. And if you want to have a look on that, we can open, for instance, the wholesaler. There is one Kanban is destroyed, is sent to the retailer. And we can also have a look on the retailer position. Retailer, where are you? We have 4 retailers. So there is one delivery to this retailer, one delivery to this retailer, one delivery to that retailer, and fourth one, we have here deliveries. Yeah, so we have all possible Kanbans used. And that's the reason why we immediately have to model now the producer. To do so, I'm deleting again the workaround. So the source, the sink is deleted. I delete this connector if I can catch it. Catch me if you can. So I can't catch it. So a different approach. We go to the wholesaler, go to the connectors. This is the not connected connector. I'm deleting it and we're done. So perhaps I should save this model. Good. So what we are going to do now is we are generating the processing of the agent producer. Let me switch to the outline. This is how it looks like. So it looks similar to the wholesaler. So that's the reason why we're going to copy the blocks from the wholesaler. And then we add the processing station. And then we have to adjust all blocks immediately. We have the functionality of the producer. So back to Anylogic, we copy it. The logic is tired. We copy that one. Control C. We go to the producer. We enter it in the producer. Logic pops up. Good. Then we need space here because here the processing appears. So I move the up. I delete this connector. So have it. I connect the move to button disease block. So then we can get rid of the exit and enter blocks. And we go to the palette, to the process modeling library. We select a queue. We rename that to queue underscore station underscore 1. We need the delay block. We rename that one to processing station 1. We connect them. So when it's empty, we go into our production, the queue first, the processing. Finally, we send the items back on system. And it would be nice if there would be again a connection. Now it's not red anymore, so this one is fine. Then we need 3 parameters. Perhaps I put down there. So the agent library, first parameter, the parameter is called Kanban dot size 1. This parameter is called proc underscore time underscore 1. The final one is called setup underscore time underscore 1. So point 59. So the Kanban lot size parameter is an integer, and the value should be 10. Processing time, the proc time parameter is a double, and hours do we have for the processing? 2 hours. And the setup is again a double, and it's 1 hour. So now we can include those values into the processing station. So we go to the queue station one. We set that to maximum capacity. We change the agent to order. We go to the processing. We change the order, the agent to order. And then we change that to hours. Now we can combine the parameters. So what we are doing is we have the Kanban lot size. Kanban lot size. We multiply that with the proc time. So this is a deterministic behavior, but the proc time is now per piece. That's the reason why we multiply it by the Kanban lot size, and we add an exponential distributed setup time. Now it's correct. Control space finds exponential. Use the first one. Screen for you. And now we have to give the production rate, or the setup rate to be more precise, but we only have the setup time itself. So we have to make sure that we get in this argument of the exponential function and rate. So we divide the time 1.0 divided by the setup time. And the 1.0 is needed that it is not an integer division. Yeah? So it could be that you get 0.3 out of this division, and then Anylogic or Java interprets it as an integer division, and the result is 0. But we want to have a double division, so that's the reason why we need the 1.0. So this is a double value divided by a double value, and then we have the double division for it. So we go to the C's block. Window smaller. We go to the C's block. In the C's block, we have to delete that one. We delete that one. We click here, units of the same pool, alternative resource set, and then it looks like it looked in the wholesaler, and then we can add the resource pool truck PR. Also make sure that the order agent is selected. We don't need that comment. And that's it. So now we go to the block start resource. So for this one, we have to make sure that the correct type is selected. In this case, we are dealing with the drug PR agent. The packaging is the same. Uniform distribution is again the drug PR. So since we have changed that, in the following agents hopefully will change as well. So we check that. This is Perfect. And in the wholesaler, we want to go, this is wrong because it's not the retailer. That should be to wholesaler. This is not possible because you can see we have used already that one. That means I have to change that one first. This is to producer. I can go back to the wholesaler one. I delete the one. And then we want to send just the item, the wholesaler by main wholesaler. Now you can see this is more slim than we had in the agent wholesaler, because between wholesaler and producer there is a one-to-one relationship. We exactly know where to go. In the wholesaler part, we have to send it to the customers, and it was a 1-to-4 relationship. So in this case, it's much more easier. So we go to the producer, and here we have to change the agent. So this is main producer. So we are going back to the producer, and we change the agent type to truck PR. That's it for the producer. So, and then there is a final block. The exit RT should be renamed to the exit wholesaler, and we have to send it to the wholesaler. So we send it to the main wholesaler, but we send it to the enter action. Take. So when we go to the wholesaler, the enter PR is exactly this one. So this one means the items are produced and now available in the FGI, the wholesaler. So we go back to the producer, and then one block is missing, the enter RT. We just have to rename it for the wholesaler. So here the agents of the wholesaler arrive in the agent producer, and we go to Kanban logic. Debug it now. We have no mistakes, so I'm happy to run the final model. So that was step 68, and the model pops up here, and we can see the trucks are driving. Of course, your job now is to validate if the functionality is working. My recommendation is go to every agent we have generated. Does that make sense? If there are a lot of orders arriving and we only have 34, 37, 39, 40 orders delivered, you can select here all retailer agents. You also have to check if the wholesaler procedure is working. We are delivering a lot is on transit. And of course, the final agent is the producer. Here we can see that we are going to produce. So, of course, you can extend the model. You can include more items which are requested by the customers. You can include more complicated production processes. You can include more players in the supply chain in total. And of course, you have to include somehow key metrics to measure the performance on the system. This is easily done. You need that for the parameter variation experiments or for experiments in total to analyze the behavior of the system. So my recommendation is go to the YouTube tutorial, Excel interface, implement the Excel interface in this supply chain model, and then you can transfer your data to your Excel model, and then you can analyze it by the experiments you have chosen. Good luck with modeling supply chain network.